Well, I had completed an entire video for you with the labor efficiency and rate variances, and then the screen went black, forcing me to re-record. So for these labor and efficiency and rate variances, I've already got the solution worked out, but still follow along. I will show you the process. So a labor efficiency variance really is no different than a quantity variance. Look at this that I put up here. This is the formula we used for the materials quantity variance. Well, guess what? Labor efficiency is just measuring the quantity of labor that we're using, whereas materials quantity is the quantity of materials we're using. Both of the formulas have plenty of parallels. Actual quantity of materials used, actual hours of labor used. Standard price per ounce of material, standard rate per hour of labor. So you can see the formulas really are nearly identical with just some changes in terminology because it's people instead of things. So plugging this in here, the actual number of labor hours was 1,910. The standard rate, in other words, what we're supposed to pay people, is $13 per hour. The actual number of hours, or the standard number of hours that they should have worked, is 1,960. Let's look at where we got that from, because that was not directly given to us. But we know that we produced 4,900 things, units of finished goods, and everything should take 0.4 hour, so 24 minutes per unit. So that means collectively our employees should have worked 1,960 hours. That's great. Well, they only worked 1,910 hours. So even before, obviously we know the answer here, but if I even if I want to take a quick kind of high-level look, I can see we saved 50 hours. 50 times 13 is 650. I can just right there identify that we have a $650 favorable variance. But we can take it a step further by figuring the total labor. This is what the labor would have been at standard rates. This is the labor dollars as they actually were, and the difference is $650. I like to always take the absolute value and then you just determine that it's favorable. Now, one other thing to think about here. In this case, in this particular example, you had to figure out this number and this number. Now the thing is this, you may not be given the actual price, I should actually point to this one here, of labor, the actual direct labor rate. There might be instances where you need to calculate that. Okay, just kind of think about that as well. The labor efficiency variance really is no different than the materials price variance. The structure of the formula, very similar. Here's your materials price variance. You can see actual quantity of materials, actual quantity of hours, actual price per ounce, actual rate per hour of labor. So the labor rate variance is simply a price variance for labor instead of things. The formula is already laid out. As I mentioned, I already calculated this, and then we had a technical issue with the video. So actual hours times the actual rate. So this really would match up to the payroll that we actually paid to our employees. And then this is actual hours times the standard rate. So you can see that our labor rate is 60 cents lower than it was supposed to be. So I can already tell you that, you know what, it's going to be 0.6 times 1,910 hours, which, by the way, is $1,146, and that's going to be favorable. Okay, it's going to be favorable, and the reason it's favorable is because our wage rate was lower than what we had planned. Remember that a favorable variance tends to make profits bigger, and an unfavorable variance tends to make profits lower. That's the way to think about it. So we do have this as a favorable variance. I would like to point out finally that it's completely conceivable that you could have a question where you don't know the labor rate, but you do know total, well, this number right here, you do know total labor costs. So in that kind of an instance, if you needed to arrive at a labor rate, It's easy to do that. You would just have to back into it. $23,864 divided by 1,910 hours. You could certainly put a little bit of math, get your calculator going. 23,864 divided by 1910, and you could figure out that the average labor rate was $12.49 per hour, which we see, well, right there. Did I make a mistake? Let's see if I did make a mistake here. I don't think I did. 23,684 divided by 1910. No, that's correct. $12.40 per hour. Okay, so certainly you should be prepared to do that. If you needed to look at a labor rate and it's not given to you, then you're going to need to calculate it using a formula like this. So in this case, we are simply we're starting with total and we're going to the rate. Okay, and that's the labor efficiency and the labor rate variance.